If you think AI is ready to design the next generation of silicon, researchers at UC San Diego and Columbia have some bad news for your GPU. While we've seen AI solve math puzzles and write decent Python, it turns out real-world chip design is still a brutal boss fight that no frontier model is currently winning. The problem? Most AI benchmarks for Verilog, the language of chips, are too easy. They test simple modules that are 10 to 70 lines long. In the real world, industrial Verilog models are over 10,000 lines of pure complexity. To fix this, the team built ChipBench, a benchmark designed to see if models like ChatGPT and Claude Opus can actually handle a professional workflow. The result? A total reality check. No model is great at real-world Verilog yet. When it comes to writing CPU IP modules, the literal brains of a computer, the highest score was a dismal 22%. That's a shared trophy for Claude 4.5 Opus, Gemini 3 Flash, and GPT 5.2. If a human engineer scored a 22 on their performance review, they'd be escorted out of the building. ChipBench doesn't just look at code generation, it looks at the two things that actually eat up an engineer's time: debugging and reference model generation. In the industry, for every designer writing code, there are up to 5 verification engineers writing reference models to make sure that code actually works. On this task, the AI basically fell off a cliff. For non-self-contained modules, the kind that actually exist in complex systems, the pass rate for reference models was a flat 0%. Debugging was slightly better, but still, no model cracked the 50% success rate. Even when the researchers gave the models one-shot help with simulation waveform data, the AI struggled to find the bugs. In hardware, a single bug can cost millions in bricked silicon, so mostly right is just another way of saying expensive paperweight. What this matters is that out-of-the-box LLMs are still far from being ready for industrial integration. They work okay for isolated, simple snippets, but they fail when they have to understand how a specific module fits into a 10,000-line hierarchy. The takeaway? AI isn't going to replace chip designers next week. We've seen specialized AI build chips before, but those were highly scaffolded systems with massive guardrails. Until we build better frameworks to teach these models the nuances of hardware verification, the humans are still the only ones keeping the magic smoke inside the chips.